Hello, academic staff around the globe. Welcome back to Caltex Academy. In case you're new, my name is Julius and thank you for clicking on this video. So in today's video, this is episode number 2 of our series of Earth geometry. So in episode number 1, we look at comprehensive introduction to Earth geometry, where we look at reasons why we study Earth geometry and also the relevant formulae that we shall be using in our video today. So if you are curious about that video, I've linked the card in the right hand corner of your screen. You can go ahead and click on that card and watch that video one before you continue with this video. And again, the link is in the description of our video here. So without further ado, come closer and let's dive into the video. So we're going to look at two questions, and our question number 1 says, find the distance between two towns P with 25 degrees north and 105 degrees east, and Q has coordinate of 35 degrees south and 105 degrees east. Now you can see they share the same longitude, and that is the reason why we say they are on the same longitude. So without further ado, let us have some sketch in our diagram here. Now if this is the 0 degrees latitude and that is equator, we can have our estimation here and the continuous the other side, so we can use dotted line to have our estimate of the reference points of measurement, and that is the latitude 0 degrees. So we can indicate it here that this is 0 degrees east, and the other side here is 0 degrees west. So the second thing here, we have to also plot this coordinate on the surface of the earth, and looking at the first point P, we have 25 degrees towards north. Now, before we go for that, we can also indicate our points here, that is North Pole and South Pole, and perhaps we need to have some reference point, and that point is the axis, and we know the earth is rotating in that direction here, so we can take it all along up to the southern hemisphere. So you can see from here that along this side up, that is the northern hemisphere, and below the 0 degrees, that is the southern hemisphere. So this is also at 0 degrees along north, and this one is 0 degrees along east. So this is our reference point, and we can also draw Greenwich meridian to be passing here. For now, it's not necessary. So let's take a look at the first point and estimate it up here. Now, the first point is at 25 degrees north, which is passing from maybe here. We're just making some estimation, though it's not accurate, but at least you get the point. So this is 25 degrees in the northern hemisphere. Now let's also finish this eastern longitude. So since it is 105, and if we assume this to be our Greenwich meridian, that is 0 degrees longitude, we can measure outward and should be far from the center because the degree there is a little bigger. So we can go on and draw that longitude here. Let's join it like that. And this point is where our P is. So we have P at this point. Now the next thing we have to do is to also locate point Q. And Q is in the southern hemisphere because we have S as our first latitude there. So what we have to do is to also estimate, and remember this is 25, is nearer to this point, and then 35 should be a little bit far from the latitude 0 degrees. So if this is our degree, that is 35, we can maybe indicate it here, south from the reference point. Now it passes through a center here, and also we have a center in that horizontal surface. I think this one's not looking all that very fine. Let us try to a little bit correct it so that it looks like real maths. Now, where these 2 points meet, again, it gives us the point Q, and point Q is here. So we give that labeling. Now, one thing we have to also note here is to join this point to the next point here, and we can call it small r. The reason why I'm giving us r there is so simple to see how we can get the angle difference between the two. Most videos can just only tell you that if you have two coordinates situated in a different hemispheres, you simply add, and I want to show you how that addition comes about using geometry. So we need to draw this line, and again we also need to join the center of the Earth or to our point that meets this in which down P and Q passes through. You can see from here this is a right angle. Likewise here, this is also a right angle. Now the next thing we have to do here is all these three lines are parallel, but our main interest is the distance from P up to Q. So we can as well join these points to the center of the Earth. So when we join this to the center of the Earth, and we also join P to Q, we'll have something like that. And this one is the radius of the Earth. Likewise, here is the radius of the Earth. So this is parallel to this and also parallel to that. So our distance we're interested at is here. Now we'll have certain angle here called theta. What we're dealing with here is this part here, starting from here like that. Now we know that from our introduction, between this line or the small radius r and this capital radius r is the same as this 25 here. So if this is 25 and this is a z angle, then we know that from here up to here is also 25 degrees. Now the same thing applies here, meaning if this is 35, the angle from here up to this horizontal layer is also giving us 35. And because it's also z angle, this horizontal line is parallel to the horizontal line here, then we'll have this 35 also subtended to the center here. And for that case, if the two towns are situated in different hemisphere, we add, that is where the origin comes from. So the angle difference for now is theta, as we have indicated it here. And this is equivalent to the sum of these two angles, and that is 25 degrees plus 35 degrees. So if you add this together, we get 60 degrees. Now, if you wish, you can extract what you have shaded here out, and you will have something that looks like this. So from here, you can see that we have this portion that we extracted it out, and we are interested in getting this distance. Maybe we can highlight it also using a different color. What we have to do is to quote the formula we have already learned. P Q is given by this angle. We can call it theta because that is what we indicated here. Otherwise, you can call it anything of your choice. And we have here 360 as the center degrees times 2 pi and r as the radius of the Earth. Or you can also go ahead and reduce this, and you quote your formula as PQ equals theta over 180 degrees, because 360 by 2 goes to 180, and that is pi r as the formula. So you can see if you're using 180 degrees here, then we have to write only pi r. But if you're using 360, then you have these two. The reason why we hit 180 here, because the 2 will have cancelled it down, but otherwise, this is our original formula, and this is just derived from what we have here. Now, after that, we can now go ahead and make substitution to our formula. Now, we were given earlier on that the value for r, or radius of the Earth, is 6,400 kilometers. So, theta is 60 degrees over 360. Feel free to use this formula also if you wish. And we have 2 terms. The value of pi was given to us as 22 over 7. And we multiply this by the radius of the Earth, that is 6,400 kilometers. Now we can get our calculator and enter everything to see what we will get from here. So let's have 60 over 360 multiplied by 2, also multiplied by 22 over 7 multiplies by 6,400. And this one gives us 6,704.6. So we first write the accurate results here, and we estimate it to 3 significant figures. So we have here R, Q is equivalent to 6,000. If we are not told the degree of accuracy, then we can go ahead and make this one to 3 significant figures, and we have this as approximation of, this is P, not R. So we have here P, also there P. So we have there PQ and also PQ. So our PQ is approximated to 6, 7. Since this one could not round to 1, we just give there 0 and 0, and that is kilometers. So that becomes the distance between these 2 points, P and Q. In case you have some question, please don't hesitate to drop it in the comment section. I will just get back to answer them for you. Now the next thing is, let's move to question number 2 of this video. Yep, in question number 2, it says find the distance between 2 towns, W with 25 degrees north and 105 degrees east, and X 65 degrees north and 105 degrees east on the Earth's surface. Take pi as 3.142 and the radius of the Earth as 6,370 nautical miles. So here we also do the same thing. We have to locate these 2 points on the globe, and first of all, we need to also estimate our latitude, that is 0 degrees. But if you wish, you can leave it out. For the purpose of repeating, let me do it for you here. So we have to estimate our latitude, and again, we have to see our first point W, and that is 25 degrees north. So 25 degrees north is some maybe distance here, where you can have that estimation. And we also have this dotted line representing the same latitude moving in that direction. So O is the center of the Earth. Let me indicate this point here as the center of the Earth. And here, this is 0 degrees is as our latitude. Now, this one is our 25 degrees north. And we notice that this is also north hemisphere. All of them are in the same side. So the second line in our first point here is 105 east. Now again, it's always good to indicate the North Pole and the South Pole, because that is the reference point where the longitude will meet. So we have to estimate it here. Let me come from down and measure it like that. So though it's not accurate, but at least we get the idea. The meeting point here gives us point W. And the next we have to estimate also is the second point X, that is 65 degrees north. Now we can pick another color to represent that, and we bring it somehow far here, and we draw that latitude. So we can estimate it there, and we call this as 65 degrees in the northern hemisphere. Remember, all these measurements are with reference to the center of the Earth here. Now, let me make some estimation of the radius of the Earth along this side. Also, this one has a center around here. Remember, all the centers lies in the axis here. So we can join also this center to this point. And remember, this point is point. Maybe we use a different color here because there's too much of this color. That point is X with this coordinate. Now, this is the small radius for that point. And if we join again this to the center, we will notice that these three radii are parallel to each other. So if they're parallel to each other, meaning any point we join from the center of the Earth to these 2 points will give us the distance here, because we'll do all the calculations with reference to the center of the Earth. Now from here we can also join this to this point here. Now let us assume that this one is a part. Like, I think the best one there, we can illustrate it with Pisa. Let's take a look at Pisa. Yep. So from here you can see this is X and W. If this part here is like this small piece of pizza being displaced from the origin, then our X will correspond here and W will correspond here. And the whole geometry looks like we're moving from here, that is the center, and then we're moving from here, we're also going like that. So our center is somewhere here. Oh, now we need this angle here, theta. Exactly, that is our angle. Now we can call our angle here theta. I think let's use this brighter color here so that the contrast is clear, like that. And so how to get this angle? Remember, all the angles are measured with reference to the 0 degrees from here. Meaning the first angle, that is 25, is measured from this part like this up to there. And the second angle, maybe we can take this green, and that is 65. From here is also measured from the center of the Earth horizontally, that is 0 degrees there. Now, for us to be able to get only this part here, we need to subtract this angle away from the other angle in order for us to get this exactly. And that is the reason most teachers will tell you that if the points you are getting the distance are in the same hemisphere, being northern hemisphere or southern hemisphere, you just simply need to subtract to get the angle difference. And that is the origin. You can see from here clearly that the biggest angle minus the smallest angle will give us this angle here. That will give us a kind of this pizza shape to be able to get this distance X and W, or W and X. I think you have gotten the idea well. Now from this point up to X is the same as the radius of the Earth, R. Also from this point, that is the same as the radius of the Earth, R. Now we can go ahead and extract it out and put our formula as before. So since we've already extracted it out, and we can take a look at the angle difference, theta is equivalent to, if you wish, you can make some mini substitution here where we call the first one here, that is the biggest one, as alpha being equals to 65 degrees, and beta being the small one here, and that is 25 degrees. So the angle difference theta is subtracting alpha minus beta. So when we subtract the two, where we make this substitution of 65 degrees minus 25 degrees, we get our angle difference as 40 degrees. So that is our theta. We have just gotten it here as 40 degrees. And this is the radius of the Earth, which we know that it is, according to this question here, is 6,370 nautical miles. So it's the same also area here. Now we can go ahead and calculate this distance. What we have to do is to quote the formula to get the distance between W and X, and we say our XW is given by, let's use the second approach of the formula, which is our theta over 180. Since we've already seen a calculation with 360, and remember, we don't need to write the 2 here because it has reduced it to 180, and that is the radius of the Earth. Now we can make our substitution. Our theta is 40 degrees, then 180 degrees times the value for pi, according to the question specification, is 3.142, and we multiply it by the radius of the Earth as 6,370 nautical miles. So we also get our calculator and work out together, where we had 40 divided by 180. We have to multiply it by the value of pi, that is 3.142. We also multiply it by the radius of the Earth, that is 6,370, and this gives us 4,447.67. So let's write this one down and have there 4,447.67 and 556. So since we have not been told, it's always good practice to make it in 3 significant figures. Now the distance of XW is approximately 2. When we round this up into this, we have 4,450, and that is nautical miles. So that becomes our distance between the two towns, X and W. Thank you for watching up to this time. If you have got value from this video, go ahead and subscribe to the channel, like the video to post it to many audience, and then share with your friends. Sharing is caring, and that is the least you can do to support this channel. Thank you very much. See you in the next video, where we're going to look at also getting distances along the latitude. We looked at longitude, so we'll look at latitude in our next video. So thank you, and see you in that video. Peace out.